Good day, guys. This is your Sir A. I'd like to share with you my knowledge in solving engineering problems, particularly electrical engineering problems. So, if you are struggling on this, want to know more about this, or even just want to watch these review tutorials, this is all for you. God bless. So, sa video na to, pag-aaralan natin ang unang bahagi ng electrical engineering o yung tinatawag na fundamental concepts of electrical engineering. At mag-start tayo ngayon sa resistance. So, sino si resistance? At ano ang mahalagang ambag niya sa electrical engineering? So, alam niyo naman na ang resistance or alam natin na ang resistance ay mahalagang parameter o mahalagang bagay sa electrical engineering. Bakit? Kasi ito ang pumipigil sa daloy ng current. For its definition, resistance opposes the flow of current. At meron tayong tinatawag na ability ng material para mag-oppose ng current. At that is the resistivity. Okay. So, resistance is being affected by several factors. Ang resistance ay may ilang mga bagay na nakakaapekto sa value nito. At meron tayong 4. At ang unang 3 ay introduce ko sa inyo sa pamamagitan ng formula. Okay, kung nakikita nyo, nakaproject sa board ang isang formula na resistance which is equal to rho L over area. Itong formulang ito, nandito na yung 3 unang mga factors na nakakaapekto sa value ng resistance. Ito ay ang resistivity, or yung kind ng material, o kung ano ang conductor, o ano ang nature ng conductor na ginamit nyo. The second one is the length, and the third one is the area. Okay, so pag-usapan natin yung 3 mahalagang bagay na yan. For the resistivity, again, rho is the resistivity. Again, it has a denotation of Greek symbol, rho. For the resistivity, meron tayong 3 most commonly used conductor. We have the hard-run copper, the annealed copper, and the aluminum. Again, we have the hard-run copper, the annealed copper, and the last one is the aluminum. So, bakit may 3 mahalagang bagay dito ng commonly conductors or most commonly used conductor? Pag-uusapan natin dito kung ano ang resistivity ng bawat isang yan. For the hard-run copper, we have 2 division of units. Meron tayong unit in MKS and also unit in English. So, for the hard-run copper, we have 1.77 times 10 to the negative 8 ohm meter. For the annealed copper, we have 1.72 times 10 to the negative 8 ohm meter. However, for aluminum, we have 2.83 times 10 to the negative 8 ohm meter. For the English unit, the resistivity for hard-run copper has a value of 10.5 ohm circular mil per feet. For the annealed copper, we have 10.37 ohm circular mil per feet. And for the aluminum, we have 17.1 ohm circular mil per feet. So, gagamitin nyo ang value ng resistivity depending upon the unit of length and also the unit of area. So that support to sa value ng ating resistivity. Okay, so pag-usapan naman natin ang length. Sino naman si length? Length is simply the haba or igse ng conductor na gagamitin nyo. And for the area, meron tayong i-introduce sa dalawang formula for area, which I know the first formula ay familiar na kayo. Kasi yun ay madalas natin gamitin kasi most conductors are circle. At alam natin ang formula ng area of a circle. So for the area, we have a formula of pi over 4 d squared. I'll be introducing to you another formula for area. And another formula for area is equal to d squared. It's just d squared. What is the difference between the two? For the area which is equal to pi over d squared, you can use this formula if your diameter is any units or has any units. And however, if your diameter has any units, your unit for area is square unit. But you can just use this formula if and only if your diameter is in mils. Question, pag ang diameter ko ba ay naka-mils, can I use the first formula? Yes. The answer is yes. However, can I use the second formula? Yes also. Definitely, if your diameter is in mils or has a unit of mils, you can use both of the formulas. Ano magiging pagkakaiba niya kung gagamitin mo ay ang diameter may mils at ang gagamitin mo both of the formulas? Okay, this will be the difference. Again, I want to reiterate that the area is equal to pi over 4d squared. You can use that formula if your diameter is in any units. Example, if my unit is meter, my area is square meter. If my area is centimeter or my diameter rather is centimeter, the area is square centimeters. However, if my diameter is mils, my area is square mils. But if I'm going to use this formula, area is equal to d squared and my diameter is in mils because that's the only unit of diameter you can use or you can apply to that formula. Your obtaining unit for area is circular mil. Again, I'll be reiterating, your area has a unit of square mils if my formula is pi over 4 d squared. And your area has a unit of circular mil if my diameter is d squared or has a formula of d squared. If I'm going to divide it, I'm going to have versus analysis. I'm going to cancel out the d squared. Therefore, I will have the relationship of area in square mils, which is equal to pi over 4 area in circular mils. Therefore, in every pi over 4 area of circular mil, there is an area of square mils. Sana nakatulong ito sa inyo. I'm going to cite some examples. So, sa example na to, meron tayong substation bus bar na meron pong diameter na equal sa 12 or 2 inches. Then we have the length which is equal to 20 feet. And also the rho or the resistivity which is equal to 1.724 times 10 to the negative 6 ohm centimeters. We are asked to find for the value of the resistance. So we will be using the formula R is equal to rho L over area. So we have the rho, we have the L, and we have the area. So anong bearing ng problem na to? So mapapansin nyo, we have different units. So unit analysis lang gagawin natin. So we're going to convert it all to one single or a single unit para mas madali nating ma-cancel ang mga ito. So that will become, our rho is 1.724 times 10 to the negative 6 ohm centimeter times length, that is 20 feet. So let's convert feet into centimeter. That's 12 or 1 foot has 12 inches. Cancel foot times 1 inch has 2.54 centimeter. Cancel the inch. So we have here the centimeter times centimeter is centimeter square. So for the area, that's pi over 4 d squared. So our area is 2 or the diameter is 2 inches times 1 inch has 2.54 centimeters squared. So centimeter squared, centimeter times centimeter is centimeter squared. So let's cancel this out. Upon using your calculator, we will have our R which is equal to 5.19 times 10 to the negative 5 ohms. So this will be the value for the resistance. Again, for the area, we use the formula pi over 4 d squared. So it's just a unit analysis. So sa example naman na to, we have the American wire gauge wire which has a diameter or effective diameter which is equal to 9.26592 millimeters. We have to determine the cross-sectional area which is a unit of MCM. So for the area of MCM, we can be able to find that if we're going to convert first, the easiest way is to convert first the diameter to mils, 26592 millimeters. So times, it will be 10 millimeters in 1 cm times 2.54 cm in 1 inch. And we have 1,000 mils in 1 inch. So cancel the inch, cancel the centimeter, and also cancel the millimeter. We will be arriving on the answer of the diameter in mils, which equal to 364.8 mils. And this time, we can now be able to find for the area in MCM. So area is equal to just d squared. Kasi sabi ko nga po, gagamitin nyo ang d squared kapag ang area nyo ay makukuha yung unit ay circular mil, provided that the diameter here should be in mils. So that will become 364.8 squared, and you will be arriving on the answer 133,079.04 circular mil. So in getting area in MCM, M here stands for 1,000. In the Roman numeral M stands for 1,000. Let's just divide this by 1,000. Therefore, area in MCM is 133.079 MCM. So this will be the answer. Again, M stands for 1,000. Okay, another thing that you have to remember in solving for the resistance, which we have the formula R is equal to rho L over area, is when a certain conductor undergo to a drawing process. So, sino si drawing process? When we say drawing process, a certain material ay nag-undergo o dumaan sa pagbabago in terms of elongation or compression. So, ideally, may pagbabago sa kanyang length or certain area. So, I'll be starting my derivation to R is equal to rho L over area, as if we're going to multiply the original formula to L over L. So, what will happen? So, in this case, we can derive rho length times length is length squared over area times length is volume. However, in this case, we will be multiplying area over area. So, R is equal to rho length times area is volume over area times area is area squared. So, we will be starting our derivation through drawing process by these two formulas. So, paano yon? So, tandaan nyo, kapag may nag-undergo ng drawing process, depende yon kung same material or different material. So, when we say same material, their resistivities are the same. So, when we say same material, the resistivity of the first conductor is equal to the resistivity of the second conductor. However, kapag different material, the resistivity of the first is not definitely equal to the resistivity of the second. So again, we'll be starting from this. So, in the same material, we will be assuming that the volume is constant. Okay, in this case, let's start our derivation to these formulas. So, R is equal to rho L squared over V. I'm going to divide it by another formula, rho L squared over V. In this case, we're going to have versus analysis between two materials. So, I'm going to put subscript 2, 2, 2, 2, and I'm going to put 1 here. So, in this case, since volume is constant, we're going to cancel this out. Since the material is the same, rho R equal. However, we will be deriving the formula R2 over R1 is equal to L2 over L1 squared. So, this is the formula when the material undergo by drawing process in a certain conductor and then in terms of length. Paano naman kapag in terms of area or in terms of diameter? So, let's derive. I'm going to erase this first for the different material. So, that will be R2 is equal to rho 2 L2 over V2 over, I'm going to use this one. That will be V2 A2 squared. In this case, this R1 is equal to rho 1 V1 over A1 squared. So, in this case, again, volume is constant. Resistivity are the same. However, we will be deriving the formula R2 over R1 is equal to A1 over A2 squared. So, in this case, the resistance is inversely proportional to the value of the cross-sectional area. In terms of diameter, it's just simple. R2 over R1 is equal to pi over 4 In this case, I'm going to substitute the formula for area 1. That's pi over 4 d1 squared over pi over 4 d2 squared. And all of these are in squared exponent. So, cancel pi over 4. That's r2 over r1 is equal to d1 over d2. And then 2 times 2 is, this will become to the 4th power. So, in terms of diameter, that is r2 over r1 is equal to d1 over d2 to the 4th. Okay, take note of this, that the length is directly proportional to the number of turns. However, we can also say that r2 over r1 is equal to n2 over n1 squared. So, this is the formula for the resistance in terms of number of turns. So, that is for the same material. Okay, what about if the material is different? When we say different, again, their resistivities are not the same. So let's start our solving or derivation of the formula to the formula R is equal to rho L over area. In this case, there will be two constants. First is when the length is constant. I'm going to put subscript 2. And then R1 is equal to rho 1 L1 over A1. Again, length is constant. So, we will be deriving the formula R2 over R1. That will become rho 2 over rho 1 times A1 over A2. So, this is the formula for the resistance in terms of area if the length is constant. However, in diameter, that's R2 over R1 is equal to rho 2 over rho 1 d1 over d2 squared. So, that came from pi over 4d squared. So, this will be the formula for the resistance drawing process in terms of diameter. What about if the area is constant? If the area is constant, let's derive again. R2 is equal to rho 2 L2 over A2 over R1 rho 1 L1 over A1. Area is constant. Therefore, we'll be having the formula R2 over R1 is equal to rho 2 over rho 1 times L2 over L1. Simply like this. And the other one is R2 over R1 in terms of number of turns. R2 or rho 2 over rho 1 times N2 over N1. So this will be the formula naman for the resistance drawing process in terms of length or in terms of number of turns. Again, they are directly proportional. So I'll give example to further elaborate and to further explain these principles. So sa example naman na to, meron tayong dalawang magkaibang kondisyon ng resistor or resistance. Again, so sa example naman na to, meron tayong dalawang magkaibang kondisyon ng given ng length at ng area which we are asked to find the value of the resistor at the second condition. So, in the first condition, we have the R1 which is equal to 0.75 ohms. For the L1 or the length of in the first condition, we have 1 foot. And for the area 1 which has the value of 1 times 10 to the negative 5 inches square. For the condition 2, kailangan natin kunin ng value ng resistor given the length which is 200 feet and given the area which is 3 times 10 to the negative 5 inches squared. So in this case, we will be starting on the principle rho 1 L1 over A1. So pagbabago lang to. This is not a drawing process. Nagbago lang yung condition ng length at ng area. So in this case, we will be getting the rho 1 that is R1 A1 over L1. So rho 1 is equal to 0.75 times 1 times 10 to negative 5 over length 1 is 1 foot. So for the rho 1, we will be having a value of 7.5 times 10 to the negative 6. So let's not just put unit kasi makakancel lang din naman. So for the R2, so kailangan natin ang rho 1 which is equal to rho 2. Bakit equal siya? Kasi sinabi same material. So for the rho 2, L2 over A2. So for the rho 2, let's store this at A in your calculator. So A, L2 is 200 feet. And then for the A2, That is 3 times 10 to the negative 5 inches square. So, yung A natin dito, yung value ng resistivity, may unit siya na makakancel lang din ng inches square and foot. So, for the R2, upon using your calculator, we'll be having the value of 50 ohms. So, in this problem naman, drawing process na to. Bakit? Kasi sinabi na meron daw pagbabago sa kanyang diameter at may word doon na drawn. So, ibig sabihin, yung conductor ay nag-undergo ng drawing process. So, we have in the first condition, we have first diameter which is equal to 11.7 millimeters. We have its resistance value which is 0.03 ohms or 0.031 ohms. And for the second condition, we have the D2 which is equal to 5 millimeters. In this case, we are asked to find for the value of the second resistance. So, again, what is the formula that we're going to use? So, R2 over R1 is equal to D1 over D2 to the fourth or to the fourth power. So, that will become R2 is equal to what is D1. No need to convert for millimeter to meter kasi makakancel lang din po. So, D2 is 5 millimeters. Cancel. And then R1 is 0.031 ohms. So, we'll be having a value of the resistor which is equal to 0.9294 ohms upon using our calculator. So, this is the answer. So, yan naman kapag drawing process. May word na drawn. So, another factor affecting the value of the resistance is the temperature. So, sino naman si temperature sa buhay ni resistance? Okay, we all know that the higher the temperature, the higher the resistance. Or pag-init ng paligid, pag-init ng conductor, pagtaas ng resistance. And upon derivation some formula, we will be arriving on a formula R2 is equal to R1, 1 plus alpha 1, T2 minus T1. And you can also apply it through current and power. I'm going to have or to reiterate the formula R2 is equal to R1, 1 plus alpha 1, T2 minus T1. I'm going to talk about the alpha or the temperature coefficient. Again, I'm going to write the formula. That's R2 is equal to R1, 1 plus alpha 1, T2 minus T1. Again, what is this? The alpha is what we call the temperature coefficient of a resistance, of a certain value of a resistance. Okay, so the alpha is what we call the temperature coefficient, which we are going to get because it is being used or it's being necessary to this formula. What is this subscript 2 and subscript 1? That is basically the value of the temperatures or the temperatures itself. For the temperature coefficient, let us again remember the three most commonly used conductors: the hard-run copper, the aluminum, and the annealed copper. Okay, for the hard-run copper, for the aluminum, and for the annealed copper, we have the so-called zero temperature. Okay, the inferred zero temperature is being used or is being or needed to find the temperature coefficient at 0 degrees Celsius. Okay, for the hard-run copper, we have negative 242. For the aluminum, that's negative 237. And for the annealed copper, that's negative 234.5. So, it's negative because it's beyond of the 0 degrees Celsius. Therefore, it's negative. And you can just get the absolute value of it or the absolute inferred zero temperature. So, you just have to take the absolute value of this negative value. So, they're all in degrees Celsius. And take note that this resistivity or this alpha is at 0 temperature. So definitely you can get alpha 0 which has a formula of 1 over absolute value of the inferred 0 temperature. So this is very simple. So, but what if I'm going to get another temperature coefficient of a certain value of temperature? Let's say, what if I'm going to get the alpha at 75 degrees Celsius, but my given is alpha at 15? Sorry, this is the given, alpha at 15. How would it be? How can I able to get the alpha at 15 if my given is alpha at 75? Let's say, so, sorry, the other way around. Let's say, we are going to get the temperature coefficient at 75 degrees Celsius. So, the formula would be 1 over alpha 15 plus minus certain temperature to make the necessary value of temperature that we want to get. In this case, gusto natin kunin si alpha at 75 and our given is alpha at 15. So, what do we have to do on 15 degrees Celsius to make it 75 degrees Celsius? Therefore, we have to add 60 degrees Celsius. So, definitely, makukuha natin si alpha at 75. Another example, let's say, we want to get alpha at 18 degrees Celsius, but we have given of 20 degrees Celsius. So in this case, we want to get alpha at 18. Therefore, alpha at 18 is equal to 1 over alpha 20. This time, we're going to subtract 2 by 20 to make it 18. Understood? Okay. I'm going to give examples about this. Para sa example na to, meron tayong resistance at 30 degrees Celsius na equal sa 50 ohms. So we have resistance at 30 degrees Celsius which is equal to 50 ohms. And also, meron din tayo dito temperature coefficient ng copper na binigay na at 0 degrees Celsius which is equal to 0.00427 per degree centigrade. What is the temperature or what is the resistance rather at 100 degrees Celsius? So we are asked to find for the value of the resistance at 100 degrees Celsius. So in this case, we're going to have the formula which is equal to R2 is equal to R1 times 1 plus alpha 1 T2 minus T1. So let's have the temperature of each resistance. That will be, we are asked to find the R at 100 is equal to R at 30 since we have two different temperature levels. 1 plus, if this is 1, this should also be 1. Therefore, if this is 30, this is also alpha 30 times 100 minus 30 degree Celsius. So we don't have yet the alpha 30. We have R at 30. So R at 30 is 50 ohms. 1 plus alpha 30, we don't have yet the alpha 30, but we can get it through the principle I have taught, that it will be alpha 30, 1 over alpha 0, plus what should be added in 0 or to 0 to make it 30, that will be 30. So upon calculation, alpha 30 is equal to 3.79 times 10 to the negative 3 per degree centigrade. So, let's store this at A in your calculator. So, let's put A here. That will be 100 minus 30 is 70. So, upon calculation, we will have R at 100 which is equal to 63.25 ohms. This will be the answer. So for this example, meron tayong comparison ng dalawang material. We have the temperature coefficient at 0. That's negative 0.0000515 per degree centigrade. This will be for carbon, which has a resistance value which is 15 ohms. However, we also have our alpha at 40, which is equal to 0.0000571 per degree centigrade. It will be for platinum. and the value of the resistance is 12. This is also at 40 and this R is at 0. So, the question is, saan daw temperature sila magpaparehas ang resistance? So, we have to equate the resistance of the carbon equal to the resistance of the platinum at a certain temperature na magpaparehas sila ng value. So, let's start our equation to R ng carbon is equal to R of platinum. So, R at 0, 1 plus alpha 0, T, at certain temperature na magpaparehas sila ng resistance, minus 0, because that will be the second or the T1 equals to R at 40, 1 plus alpha 40, T minus 40. So, let's substitute 15 ohms, 1 plus. So, I'm going to store this at A, and then I'm going to store this at B. So, that will become A, T, is equal to R at 40 is 12, 1 plus. So, alpha at 40 is at B on your calculator, times T minus 40. So, in this case, upon having calculation, upon using your calculator, we can derive or we can have the value of T, which is equal to 93.21 degree Celsius. So, at this temperature level, magpaparehas ang kanilang resistance value.